Hi, this is a video about 10.3 problem number 25. In short, the question asks you to find a lot of different things, but asks you to do them using your calculator. So we need to find several different first order derivatives, all for when t equals, I forgot a negative sign, all for when t is -1. And so that is good. And then they want me to write the equation for the tangent line at that same location or value when t is -1, and the parametric equation is as given. Okay, so I'm going to go over here to my calculator, and I have entered in the parametric relationship. Let me just make sure I don't have any typos. I think I'm all good to go. I'm going to look at my graph. And since the question included negative values of t, I made sure to include that in my window. I didn't start at t equals 0, right? Since t equals -1 is a part of this question, I wanted to make sure my window settings included that. Now, to find all the things that were requested in the question, I'm going to use actually all of the things in this calculate menu. So one of the things I'm going to need in order to write the equation of a tangent line is a point. I always need a point and a slope. And so this tells me that I have the point 4, 2 as my location, x, y. And as I observe this, it sure looks to me like that location, or you look where the cursor is, looks like a place where I might have a horizontal tangent line. So let's see if that bears out. Let's go back into the calculate menu, and let's go ahead and find slope. So this is my slope, dy dx, and I am going to enter in -1, and it tells me, ooh, interesting. It says that my slope is -3.333 times 10 to the -7, which means I have 0.000000333. You know what? I think that's essentially 0. You have to understand that the elves in the calculator do not know calculus. They are using approximation tools sometimes, such as secant lines instead of tangent lines. I believe that to be 0. Okay, so I'm going to write that dy dx at t equals -1 is 0. Then, that's an interpretation. Then I'm going to go down here and find dy dt when t equals -1. So I'm going to type in -1. And it says that the rate of change in the vertical vertical direction, I should say, is also 0. I am interpreting 0.000001 to be 0. Okay, so I think that is also 0. And then I'm going to find dx dt, and I'm going to type in -1. It's close to a -1, but not exactly, so I'm going to get it as exact as I possibly can. And it says the rate of change horizontally is -3, which means that we are moving to the left, and that makes sense because as I saw this traced out, my little circle came around here and then went around and then up. So yes, I agree that right through this location, I am moving from right to left, okay? And it makes sense that I'm not really going up or down because that's kind of looking like that horizontal tangent. Okay, so now if I take all of that information back to my piece of paper here, the things that we just saw together, Covey, I'm using Bear's color. Oh, I was going to use Bear's colors just for you. Okay, so here we've got 4, 2 was our ordered pair. We found out that our slope we interpreted to be 0, because it was so super teeny tiny. We found out that our dx dt was -3. We found out our dy dt at -1 was 0. And the parts that I need for writing the equation of the tangent line, are this and this ordered pair. So I'm going to put those together now and say y minus a y coordinate equals slope x minus an x coordinate, which is just the same as saying y equals 2, which is a horizontal line. Oh, okay. The horizontal line y equals 2. Fantastic. So if I come back to my calculator, maybe I can take a look at that. Okay, so here's my parametric equation. And I did some fancy pants work behind the scenes. Let's see if it worked out. Ah! I made up a parametric equation that graphs y equals 2. Ta-da! Hope that helps, guys.